Our question, the reaction A plus B equal to Xc is carried out in a frictional piston, and the rate of expression is negative Ra equal to K1 Ca squared Cb. The question asks us to write the rate law solely as the function of conversion and to calculate the conversion and rate of reaction. And here is some information given by the question. Na equals to Mb, which is equimolar, V naught equal to 0.15 feet cube, and K, and this is the V equal to 0.1 P. P is the pressure, V is the volume, and T is constant throughout the reaction, and R is the gas constant.
In order to solve this question, first we need to find the mole fraction of Ya0. Ya0 equal to Na0 over Na0 plus Nb0. And since Na0 and Nb0 are mentioned as equimolar in the question, we will get 0.5 as our mole fraction. And next, the delta is obtained from the stoichiometry of product minus reactant, which is 8 minus 1 and 1, we will get 6. Next, to find the epsilon. Epsilon is the product of mole fraction and the delta, and we will get 3 as our value for the epsilon. And now by taking the general equation of variable volume of gas flow systems, we will get this equation. By substituting the values that we obtain here into the general equation, this equation will be reduced further into this form.
Okay, so now we know that Na equals to Na0 1 minus x, and Nb equals to Na0 theta b minus x. Since this reaction is equimolar, then theta b equals to 1. Given in the question, negative Ra equals to K Ca squared Cb, and we know that Ca equals to this equation and Cb equals to this. After we substitute, we get this equation, and then after we expand, and then we get this equation, and we know that Na0 equals to Ya0 P over RT0 V0, and then we substitute this A0 into this, and we get this equation, and we can cancel the V0 here, and then this is our final equation. Since we know that P0 equals to 10 V0, we can substitute the information into the earlier equation, and then we get this.
To find the conversion, we take the equation from the part A, which is V squared equal to V0 squared times 1 plus epsilon x. Then we plug in the value to get the conversion x equal to 0.259. For the rate of reaction, we substitute x into the equation 1 as mentioned in part A to get the value of 8.6396 times 10 to the power of negative 10 pound mole per feet cube per second.